We said that speed was distance over time, where we measured the total distance. Remember the dog running around Dorothy. And then we could use the term velocity if we meant displacement divided by time. So if we were focusing on the finishing and the start point. So speed is total distance over time. Velocity is when you're just looking at the start and the finish. You guys have questions? What you doing? Is it physics?
No.
Then you can put it away. All right. So the first one we did here, an object is moving in the positive direction at a constant steady speed. If we see steady speed, that means that our arrows are equal length, right? If our arrows are equal length, that means that our dots are consistent distance apart from each other. I'm just going to write consistently spaced. And so that's why down here with our motion map, we have dots that are regularly spaced. All the arrows are about the same. Our speed is 1 meter per second. But if we're considering our if we're considering our direction, we can say that our velocity is plus 1 meter per second. And then when we graphed it over here, we just said, okay, well, to be consistent between these two, this is going to be plus 1. And we're going to write it across here. Now, there's nothing in our question that says that it has to be plus 1. You might have made it plus 2, and it would still meet the criteria. So you could have also made it, no, you couldn't have made it negative. It's going to have to be positive. But you could have drawn one where your dots were consistently spaced but 2 meters apart. And then when you draw your arrows, they're still going to be consistent. The thing that's going to change is that now your dots on your velocity versus time graph are going to have to be higher up. So that's the difference there. Okay, which one should we try next? I'm going to do one more before I have you guys try to do them on your own. Number 2? Okay. So in number 2, oh, this one's interesting too. The object is standing still. So if it's still, that means that all the dots are at the same distance or the same position, right? So what position should we put them at? Anybody? How many meters? Oh, nobody just wants to throw out a number.
1.
1, okay. So I'm going to make this one 1 meter, and I'm going to put my t equals 0 dot right there. Time is 0. But my object is standing still. It's not moving anywhere. Maddie, you can go. That's fine. Thanks for letting me know. So my next dot is going to be at the same distance, but I'm going to kind of put it below it just so that I can see it. If it stays still, there it is again. T equals 1, t equals 2. I could do that forever, but I'd run out of space eventually. So what's the velocity there? 0, right? So here, I've got a velocity is equal to 0 meters per second. So when I come over here, where am I going to put it? Where's 0 on this chart, do you think? Yeah, it's probably right here, right? 0 meters per second. So I don't know. I like to grab colors for this kind of thing too. So my line's going to actually be right there. Try to make it so that we know, so if someone else was looking at your paper, they would understand that you were trying to put it on the 0 line. So you might want to make it thicker. You can put dots on it, something there so that people are like, oh, well, of course there's a line there. Every once in a while, students will say things like, oh, well, it's on the 0 line, and since that line is there, I just didn't draw anything. Don't do that. Should we do another one? Yeah. All right, which one should we do? You guys just want to do 3? Yeah. Okay. The object moves in a negative direction. So it tells us on this line, our object is going to go towards the left at a steady speed for 10 seconds. That means we're going to have 11 dots. Remember, we're going to have the number of seconds plus 1. And then stand still for 10 seconds. got different markers. I might as well use them. Okay, so my yellow ones describe one part of the motion, and then there's a change in that motion, and my object does something else. I'm going to need 21 dots here. That's a lot of dots. All right. And because I know I'm standing still for 10 seconds, I'm going to have to stack some. I'm going to start my dots on the top here. So 10 seconds at a steady speed in the negative direction means I'm going to have to start all the way on this side because I want them to go negative. I'm going to label that time equals 0 seconds so that anybody looking at that knows that that's where I started. All right, so I'm going to go 10 seconds. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, we're just sketching this. If your dots are a little bit farther apart or a little closer together, that's okay. My challenge is going to be to use this rather fat pen to draw arrows now. I'm not excited about that. Okay, so I've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Time equals 10 seconds. So I'm labeled there. After 10 seconds, my object stands still for another 10 seconds. So my position isn't going to change. I'm just going to stack these guys up here. So that's 10. Then I have to go another 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's all my dots. Okay, so arrows. I only draw arrows when my object is moving in the positive or negative direction. There's no arrows for standing still. So I'm not going to draw any arrows in here. So it's telling me my object is not moving. And so the length of my arrows, up here where we said that speed tells us about length, sorry, that the length of the arrow tells us about speed. Since these have no arrows, it tells us it has no speed and no velocity. So I'm going to draw my arrows going backwards carefully as I can because this pen is too fat for this. There's my arrows. What about velocity? What do I know about the velocity? Don't worry about a number. I know some of you guys are looking at this trying to calculate a number. Which direction is it? Positive or negative? John. It's negative, right? So if it's negative, we're going to put it in the bottom, I guess it's a quadrant. We're going to put it in the bottom part of our graph. Right? Up is usually positive, down's negative. You think it's big or little? Are those big arrows or little arrows? I think they're little. Do you guys think they're little? It's kind of because I had to put a bunch of them in there. But that means that I'm going to draw my line underneath down here. Now, it's going to move for, I have a point that matters here, 10 seconds. Right? What happened at 10 seconds? That's where my object stopped moving. So I'm going to have a negative velocity for a little bit of time up until 10 seconds. After 10 seconds, my velocity is 0. So there's a break in my line, right? It's not like my object is slowing down. According to the description, it just stops. So if it just stops and there's no transition, we're going to go from a negative velocity to just 0. What I'd like for you guys to try to do, and you can work together, is take a look at the last problem on the first page and then on the second page. And you'll notice that your information changes a little bit here. You guys see these are position versus time graphs, and this is a velocity versus time graph. How do we get velocity off of position versus time? Do you guys remember from a buggy lab? If we take a look at this graph, the slope of our line on position versus time is going to give us meters per second. What kind of thing is meters per second? Speed, yeah. It also tells us our direction. It tells us if it's going in the positive direction or the negative direction. Because here we can see that because the position is getting bigger, that this one's going in the positive direction. If we take a look at the second one, we start in the positive direction and then we shift to the negative direction. And so that means that from these graphs, we can actually tell velocity too. So here, this velocity is going to be positive. And a way to think about this to calculate your slope is to just look at the beginning and the end points. So if we just look at the beginning and the end, here our object has traveled 4 meters, right? So we're going to do the final position, which is 4, minus the initial position, 0. It's meters, divided by 4 seconds minus 0 seconds. And so we know that our velocity here is 1 meter per second. Is that positive or negative? It's going to be positive. We know it's positive because we calculated it that way. So it's going to be positive 1. So then over here on our velocity versus time graph, we can just draw a line right there at plus 1. When you do ones that have multiple segments, just think about it a segment at a time. So your slope here is going to go between 1 and 2 on your velocity versus time graph. Your slope here is going to go between 2 and 4 on your velocity versus time graph. Okay, any other questions? Hopefully that sets you guys up pretty good. If you do have questions, let me know, and you guys are welcome to talk to each other while you work on this. Okay? Awesome. You guys can have at it.